Okay, we're going to start talking about the areas of regular polygons. That's chapter 11.6. I already prefaced this chapter on Thursday where I showed you the triangle inscribed in a circle, so that way you would be familiar with where these angles are coming from. Essentially what I'm going to do is I'm going to take the number of sides of these regular polygons and divide it by 360, assuming that it's inscribed in a circle, and that'll give me the area of the measure of the central angle. So for this one here, we said on Thursday that that was 120 degrees. Okay, now just a refresher, a regular polygon is a polygon who has equal sides and equal angles, right? Okay, so today's drawings are not all going to be perfect, but just assume that they are equal sides and equal drawings. Okay, so what we're going to do is, I understand that there is an area formula for triangle, rectangle, and those regular polygons, triangle, square, those regular polygons. However, when you start getting into octagon, pentagon, hexagon, dodecagon, stuff like that, there's no formula to find the area. So you have one of two options. Some of you will be able to figure out the area by breaking it down into different regular polygons and adding those up together, calling that the composite area, for example. But there is also another alternative, and that alternative is the regular polygon formula for area, and that is area is equal to the apothem, which we're going to talk about in a second, times the perimeter of the polygon divided by 2. You might also see it like this: area is equal to PA over 2. You could also see area is equal to 1/2 times P times A. Okay, so it's going to be written in 3 different ways. All right, so let's talk about the apothem. The apothem essentially is a line from the center of the circle to the side of the regular polygon, and it's not just a line, but it's a perpendicular segment. Okay, so a perpendicular line, and so it creates a 90-degree angle. What this does in this triangle, what you'll notice is the height of this little triangle. And essentially what I want to do in order to find the area of this big triangle is find the area of one little triangle and multiply it by 3, because they're all congruent. Okay, so that's the apothem. Now, when I draw the apothem, if all of the central angles are 120 degrees, that means the apothem is going to bisect that central angle, and it's going to make this 60 degrees. Again, that's stuff that we covered on Thursday. If you're lost or forgot or you weren't there and you're confused, just come see me in the morning for tutoring, or as always in PASS. So if that's 60, this is 90, then that means this is 30 degrees. Okay? So now we have our 30, 60, 90 triangle. And so with that opens up some options in order to find some measures. Because again, in order to solve this equation over here, or this formula over here for area, we need to have the perimeter of the shape. So we need to have at least one side, because then we can just add up all the sides. And then we need the apothem. So if I was trying to find the apothem, having the 30, 60, 90 knowledge that I have, I can go ahead and say, okay, across from the 30 is a length of A, across from the hypotenuse is a length of 2A, and across from the 60 is a square roots of 3. Okay, and that will allow us or afford us the opportunity to solve for any given number of items if necessary. And we'll talk more about that as we progress through this unit. Okay, so that's basically the setup, and that's kind of part of a little overlap of what I talked about on Thursday, but I wanted to kind of get you there. The main focus is going to be this area stuff over here, and so we're going to go ahead and jump right into that with our first example. Alright, so here's the first of many bad drawings. What can I say? I got my art lessons from Jasmine, so it just happens to be not so perfect. But this is a hexagon. So if I want to find the area of this regular hexagon, I'm going to have to be given some information. Okay, so the first thing I want to do, though, is I want to go ahead and work out the central angle deal. If I want to find the central angle, okay, first of all, I'm going to draw a triangle from my central angle. So if I find the center of my circle and I draw a triangle, it'll look something like this. Okay? And so there's my triangle, and if I'm dealing with a hexagon, I'm dealing with 6 sides. So to find that angle measure of the central angle, I'm going to do 360 divided by 6, and that's going to give me 60 degrees. Now, if I draw my apothem in there, and my central angle, so that whole angle right there is 60. So this whole angle right here is 60. But if I draw my apothem in here, I'm really only going to be messing with 30 degrees here. That means this is 60 degrees. And so here we go again with our setup of a square roots of 3, and 2a. So we have that. Now that we've set up our problem, let's assume, and we're wanting to find the perimeter, so I mean, not the perimeter, we're wanting to find the area. So the area is the apothem times the perimeter divided by 2. So I need to find the apothem, I need to be given the apothem, or I need to be at least given a side. So let's just say the problem was given and our apothem is equal to 14. Okay, so we can go ahead and plug that into our formula right now if we want to get started. So the apothem is 14. Now I need to find the perimeter time divided by 2. Okay? So now I know that right here, it's not a square root of 3 anymore because that's my apothem. Instead, we're going to put 14 because that's given. So if 14 is equal to a square root of 3, I need to figure out what a is. Why do you think I need to figure out what a is? Well, I'll let you think about that while we go ahead and solve for a. So as I solve for a, I'm going to divide both sides by the square root of 3. Okay, and then I'm going to end up with 14 divided by the square root of 3. Because we're going to work with this number a little bit further, we're not going to rationalize the denominator. We're just going to go ahead and do that in our calculator so that we can get a approximated number. And so then what you end up with is a is equal to 8.1. And again, that's just 14 divided by the square root of 3. I didn't solve for, I didn't rationalize the denominator. I didn't keep it in simplest radical form because I'm going to work with that number. Now, if I find a, which is this right here, what will that give me? Because of what am I missing in this formula up here? Yeah, I'm still missing the p. I need the perimeter. So finding a will give me this, which is 14. And if I know this is bisected, I know that if this is 14, if this is 8.1, not 14, if a is 8.1, that means this whole side, this side is 8.1, and this whole side is 16.2. So now I have a whole side length of 16.2. Well, can I find the perimeter if I know the side length of one side of a hexagon? Yeah, because remember, this is a regular polygon, and so all of your sides are going to be equal. So what I'm going to simply do is do the perimeter is equal to 16.2 times 6, because that is how many sides I have. So my perimeter is going to equal 97.2. And so then now I can go back in here and plug in the rest of my formula. So area is equal to 14 times 97.2 divided by 2. Okay? And if you simplify that out, you essentially could have done 7. You can cancel those out and do 7 times 97.2. And then you find out that your area is going to be equal to 680.4. Okay, quite a bit of work here to solve the area, but not too challenging of a work, right? I mean, it is challenging if you don't know the 30, 60, 90, but other than that, I mean, it's just a bunch of little problems in order for us to fill in our formula. Okay, let's go ahead and move on to the next problem. All right, let's see if this works with the square. Now we know, and we'll talk about this more in a second, some of you should already know the area of a square is equal to side squared. So we'll talk more about that in a second. Okay? But let's go ahead and use what we learned, and let's use our area is equal to the apothem times the perimeter divided by 2. Okay, the first thing I need to do is I need to find that central angle. So I'm going to go ahead and draw my triangle. Okay, and again, if I have 4 sides, I'm going to simply do 360 divided by 4. And you'll end up with a central angle of 90 degrees. Okay, so now this angle right here is 90. If I draw in my apothem, this angle becomes 45. And so if that's 45, then this is 45. And here we are with our other special right triangle. Okay? And so if you remember from that unit, we remembered that across from the 45s we have A. They're congruent, remember? So we have A, and across from the hypotenuse, or on the hypotenuse, we have A square roots of 2. Okay? Let's say that I give you the side length of 8. So that's 8. So how do I find, what do I need now? Well, the perimeter is easy. Perimeter is going to equal 4 times 8. So my perimeter is 32. So I can go ahead and fill in my part of my area formula up here. So area equals 32A for the apothem divided by 2. So area is going to equal, okay, we got to find now what A is. Or we need to find what the apothem is. Okay? Well, I know that A is what? Okay, A is equal to 4. A is equal to 4. And the reason A is equal to 4 is because if this whole side is 8, okay, when I drop down my apothem, I'm going to cut those in half, and that means A is equal to 4. So if this A right here is equal to 4, that means this A right here is also equal to 4, and that A represents my apothem. So this is actually going to be a simple problem where I have 32 times 4 divided by 2. Okay, I'm just going to reduce it down and to do 32 times 2. Okay, and then 32 times 2 is easy math of 64. So this problem was extremely simple. Our answer is 64. But part of the reason I wanted to do this is I want to show you that it works. Okay, so I use the area of a regular polygon in order to solve this. But if I use the area of a square, which we know, right? A equals side squared. I would mean that A would be equal to 8 squared. 8 squared is 64. It's amazing how they both work. Okay? So essentially the same answer, right? All right. Let's look at another example. Because not all of them are going to be 30, 60, 90 or 45, 45, 90. At the beginning of the video, I told you that we might have to use our tangents. And so let's take a look at that. Okay. So we're going to probably, okay, so here's a pentagon. Okay, and again, we're assuming it's a regular pentagon. So let's go ahead and draw our triangle in there so we can get our central angle. So hopefully you're seeing a pattern. The first step is always to draw that triangle and get that central angle. So we figure out our central angle by doing 360 divided by 5 because we have 5 sides in a pentagon, and your central angle is going to end up being 72 degrees. Okay, and so now this angle right here is 72 degrees, making that kind of an awkward number to deal with. So if I drop my apothem in, then that 72 degrees becomes 36. This is 90, okay? So I have 90 and 36. That means the other side is going to be 90 minus 36, okay, or 54. And now we don't have the 30, 60, 90. So now you're going to have to be reliant upon your trig functions, your sine, cosine, and tangent, in order to help you out with these types of problems. Okay? Again, let's say I give you 8 as a side length. Okay, how do I find the apothem? Well, what do I know this measure is right here? Well, I know that's 4, right? Okay, I know that's 4 because my apothem is going to cut that side in half, so that's 4. So now I can use one of these degree measures to figure out my apothem. So given the 4, that's the opposite. If I use my tangent, so I could use tangent of 36 degrees, that means I need to use opposite over adjacent, right? So tangent of 36 is going to equal the opposite, which is 4, over my adjacent, which is now going to be x, or the apothem that I'm looking for, right? Okay, if we cross multiply, we're going to end up with, and I'm just going to show you every step. I know not all of you do this. The x times the tangent of 36 is equal to 4, because I'm multiplying both sides by x, and that cancels that out. Then I need to get rid of the tangent, so I'm going to divide both sides by the tangent of 36 to get x by itself. So I'm doing some flip-flopping. End up with x is equal to 4 divided by the tangent of 36. So x is equal to, if I plug in tangent into my calculator, okay, so 4 divided by tangent of 36 is 4 divided by 0.7265. And then you do 4 divided by that, and you end up with 5.5. So quite a bit of work there to find the apothem, but now I have the apothem being 5.5. The perimeter is easy. The perimeter is going to be equal to 5 sides, right, times 8 is the side I gave you. So perimeter is equal to 40. And so now I can go ahead and I can work the area. So area is going to equal to the apothem times the perimeter divided by 2. Area is equal to 5.5 times 40 divided by 2. Or area is equal to 5.5, reduce that there, times 20. Area is equal to 110. All right, and that is how you find that. And that, again, that is a regular polygon, but when I find that central angle, it does not give me 40 special right triangle. It doesn't give me the 45, 45, 90. It doesn't give me the 30, 60, 90. Instead, I have to use a trig function in order to solve. All right, one last example, and this time I'm going to show you something different, okay? Let's say we're told that we're working with a pentagon. An octagon. Okay, so an 8-sided figure. So right now, I'm telling you, without drawing a picture, you're working with an 8-sided figure. So what have we been working with the whole time? The first thing that we do, because some of you might be sitting there thinking, like I know especially Jasmine's thinking, I can't draw these shapes, blah, 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 blah. Okay, so what are you thinking then? The first thing that we do every time, so far on every problem, was to essentially draw a triangle, right? So without drawing the octagon, let's just draw the triangle. In fact, let me make it a little bit bigger so we can have more room to see our work. So we're going to just draw a triangle, okay? Now, I told you we're working with an octagon. So what's the central angle? Well, 360 divided by 8 is equal to 45, right? So our central angle there is 45, but let's go ahead and drop our apothem in. Let me go ahead and write up here octagon so we know what we're dealing with here. Whoops. Oh, that's terrible handwriting. Here we go. Let me fix that. Wasting time. So we're dealing with an octagon without drawing the picture, okay? So our central angle is 45. Drop down my apothem here. And here I have my right angle. Central angle is 45 now, so if I divide that by 2, this angle here is 22.5. Okay? Now, let's say I give you this whole side here is 9. So this side right here is 9. Not just the partial side, the whole side. So that means that this side right here is going to be 45. 4.5, excuse me, not 45. So this is 4.5. Now, let us go ahead and figure out what the apothem is. So I'll make that A for the apothem. How do I find the apothem? Okay, again, just like last time, I'm going to do tangent of 22.5 is equal to opposite, which is 4.5, divided by the apothem. Okay, so and again, just to shortcut it, A is equal to, just switching the places, A is equal to 4.5 divided by tangent of 22.5. So as we work that out, I'm just going to do the whole thing in my calculator now. 4.5 divided by the tangent of 22.5. And you end up with something along the lines of 10.9. So the apothem is 10.9. So A is equal to 10.9. Now again, going back to our formula for area of a regular polygon, we're going to do the apothem times the perimeter divided by 2. Okay, so we know the apothem is 10.9. Now we just need the perimeter. What is the perimeter? Well, remember, we're working with an octagon, right? So the perimeter is going to be equal to 8, 8 sides, times 9, because that was given to you earlier. So my perimeter is going to equal 72. So then I have 10.9 times 72 divided by 2. So then my area is going to equal, again, I like to reduce 72 divided by 2. And I would do 10.9 times 36. And then an area would equal roughly 392.4. And again, I didn't have to draw the entire octagon in order to do this problem. I just drew the triangle that I'm working with because I'm not really working with the entire octagon. I'm just working with that little triangle because once I have that, that'll help me find the apothem. And once I find the apothem and I can find the perimeter, I'm good to go. And that's pretty much it for this section. If you have any questions, please let me know. Always can get me at misdgeometry@gmail.com or just come see me in tutoring. Other than that, you guys have a great weekend.